standpoint is vicariance. So vicariance means passive dispersal. So those antelope squirrels, the Grand Canyon formed, the Colorado River cut through the Grand Canyon, split that mountain in half. Those antelope squirrels didn't pick a side to necessarily be on. They were split into two populations, which eventually became two species. It was a passive dispersal. Jumping from one island to another is an active dispersal. Okay? But having an island break off and form while you're on that island, Australia is a good example. When we talk about vicariance, a great example of this is the Australian mammals. Okay. Australia broke off the rest of Gondwanaland early in mammalian evolution, and so you had you sort of captured time in a bottle, and using the functional marsupials. Madagascar is another good example. Primate evolution was happening when Madagascar broke away from Africa, and so you have captured a bunch of extinct primates on this one island, and evolution of primates continued in Africa, but it sort of time stood still in Madagascar. You find fossil aye-ayes and fossil lemurs in Africa. So we know they were more widespread. It's just that they were replaced in Africa by other primates, more evolved primates, that never made it to Madagascar. So another example would be Madagascar primates. Okay, so here you have a vicariant event. You have an island here, or a landmass, whatever it is, it's split into two. So this could be the Grand Canyon form, splits into two, and then you end up with two different species because of this geographic barrier. So it didn't have anything to do with the active dispersal of the species. They were sort of passive in this process. Again, and then you can have a founder event. This would be an active dispersal, or you have moving from the mainland to this island, and then after isolation, it becomes two different species. We'll come back to this vicariance versus dispersal, because it's for a long time it was a debate in the field of biogeography. What degree vicariance versus dispersal played in the history of life on this planet. So here's your elephant squirrel example. These two different species, a little hard to see. Okay. So this one has sort of a whitish colored tail and longer ears. This one has shorter ears and doesn't have the whitish color in it. So there's quite a bit of morphological divergence between these two forms. This is Oklahoma-Arkansas border, southeastern Oklahoma, southwestern Arkansas. These are three different salamander species that are endemic to a particular mountain. So this is the rich mountain salamander. If you drive the Talamina Scenic Drive, actually right at the state border, there's a park on the Arkansas side, Queen Wilhelmina State Park. There's a lodge there. But you can drive this between Talahena, Oklahoma, and Neenah, Arkansas. I don't know if you guys have been to that part of the world. But kind of neat to drive this scenic drive. It's right along the ridge of Rich Mountain. If you do that, jump off when you see signs for any springs. There's a lot of springs that come out of these mountains. Horsey Springs is one. You jump off and start flipping rocks, you will find the Rich Mountain salamander. It's endemic basically to this mountain and nowhere else in the world. Go over into Arkansas. This is the Forsh Mountain salamander, and this is the Caddo Mountain salamander. That salamander is endemic to this particular stretch of the Ouachitas. Forsh Mountain salamander is found in this particular section of the Ouachitas, and the Rich Mountain salamander is found just on Rich Mountain. So they're very close. They're each other's closest relatives. They're considered sister species. They used to be one species, actually. They were Plethodon ouachiti, but they've since, in about 20 years ago, they did genetics on these guys, and there's enough genetic divergence to split them into different species. So they split them into 3 different species. This is another good example of an allopatric speciation of closely related species that are geographically separated. And they don't move much. I mean, these guys, they live under basically a rock their entire life, under the same rock, and they really don't move from that rock. If you disturb them, they might move to the next rock. But they're people who've done market capture studies, these guys, they really just don't move much. So their speciation probably dates back to the Pleistocene. Darwin's finches. This is the Hawaiian Honeycreepers. This is another example of allopatric speciation. The Hawaiian Honeycreepers are another example of allopatric speciation. So these all share a common ancestor, but they're geographically pretty divergent from one another. Notice there's an extinct species. Hawaii has has some of the most exotic species of any place on Earth. Hawaii has been greatly affected by humans, and most islands are, but Hawaii in particular has just tons and tons of exotic species. Most of the diversity on the Hawaiian Islands is actually not native. And so it's affecting these honeycreepers. These are hummingbird type species, so they're nectar feeders. So they need native plants. They're not adapted to feeding on exotic plants. And the exotic plants are taking over the Hawaiian Islands. Another type of speciation is sympatric. So sympatric speciation is within a continuous population. So there is no geographic